Hello, I'm Robbie Mochrie, and today I'm going to introduce you to part 5 of my textbook Intermediate Microeconomics. In this part of the book you will find two broad themes. The first one is about modelling behaviour in the whole economy rather than in just one market. The second one is about understanding that while markets can be a very efficient way of allocating resources, they are not necessarily perfect. In this talk, I'm going to concentrate on the first theme and think about the microeconomic approach to analysis of the whole economy. To start off with, let's think about what we've done so far. In part 2, we thought about how consumers use money to buy goods and generate utility from consumption. In part 3, we thought about how firms use money to hire factor inputs and produce goods. We also saw that firms earn revenue from selling goods to consumers, so that the product and the factor markets are closely connected. We have not yet looked closely at markets for factors of production, but we know that firms hire factors of production from people. Now, it might seem reasonable for us to model the economy as a system in which people hire out factors of production to firms. The firms make goods, and people buy and consume these goods, generating utility. In such a system, factor inputs are the basic resources which are needed to generate utility. We want to think about the whole of the economy, rather than discussing one market at a time. Keeping our analysis as simple as possible, we should have markets for at least two goods, so that people are choosing among consumption bundles in much the same way that they did in part 2. We also need to have two factors of production, so that there will be economic resource allocations made in factor markets as well as in goods markets. This means that in our simple economic system there are going to be 4 interlinked markets, 2 factor markets and 2 product markets. And of course we also need people in our economic system. This gives us what's called a 2 by 2 by 2 model. There are 2 people using 2 factor inputs to produce and consume 2 goods. As we're building this economic system, we find that we can drop some components of our earlier analysis. There will be no real role for money in our system. Instead, we will simply decide that one of the goods in our system has unit value, perhaps an hour of labour, and the other goods can then be valued in terms of labour time. We can also get rid of firms in our analysis. Instead, we will treat people as using their endowment of resources to produce goods which they then consume. Since this is quite a tricky idea, I'll explain here how I set up the model in chapter 21. The 2 people in this model are Richard and Seth. They both have an endowment of capital and labour. Richard runs a bakery, while Seth runs a creamery. The bakery produces bread, and the creamery produces cheese. You might think that this will mean that Richard takes his endowment of labour and uses it in the bakery, while Seth takes his endowment and uses it in the creamery. Then they'll trade bread and cheese. But that's not quite what we do. Our main tool for this kind of analysis is a diagram called an Edgeworth box. It shows the total endowment of capital in the economy as the length of the box, and the total endowment of labour as the height of the box. Point E shows how this endowment of factors is divided between Richard and Seth. We'll measure Richard's factor endowment from the bottom left of the box to point E, and Seth's factor endowment from the top right corner down to E. Now imagine Richard and Seth as the owners of their business, going out to the market and hiring factor inputs. The overall effect will be that some of both Richard and Seth's endowments of capital and labour are going to end up being used in making bread, while the rest will end up being used in making cheese. Production will require the use of factors at point F. Note that at point F, the whole factor endowment is being used in production. The supply of factor inputs is equal to the demand for them. We have market clearing in these markets. Now, is this the best that Richard and Seth can do. Suppose that at point F we draw a pair of isoquants. The isoquant for the bakery has the shape that you're used to seeing. Strictly, the isoquant for the creamery also has the conventional shape, but in order to see this, we have to start from the top right-hand corner. In effect, what we have done is to squeeze two diagrams together, and we've rotated one of them through 180 degrees. If you start from the top right corner and you look down to the isoquant, then in this orientation you should see that you're looking at a curve which is downward sloping and convex to the origin. The isoquant has the usual shape. You will also see that the isoquants through F form a lens shape. Within the lens, we have a set of points which lie outside both isoquants. Inside the lens, we find all resource allocations of capital and labour in which the output of both bread and cheese will be higher than at point F. Production at a point like F therefore cannot be efficient. In this context, we say that a resource allocation is Pareto efficient if it is impossible to increase production of one good without reducing production of the other one. In the diagram, we're looking for a situation in which there is no lens formed by the isoquants. That can only be possible if the isoquants touch but do not cross, as at point G. You'll see that there is also a common tangent at G. The economic interpretation of this should be familiar to you already. Pareto efficiency requires the marginal rate of technical substitution to be the same in all industries and equal to the ratio of factor prices. So familiar ideas will reappear in this new context. To explore this situation a little more, let's ask the sort of question with which we're already familiar. Suppose that Richard and Seth are already committed to producing a certain quantity of cheese. What is the maximum quantity of bread that they can produce? This is another constrained optimization problem, and we expect that the solution will be at a point of tangency on the constraining isoquant. The solution will then be Pareto efficient. And we see that at point G. Now, we can also generate something like an expansion path, showing how Richard and Seth will utilise factors to maximise bread production as the cheese production target varies. We call this a contract curve. The contract curve runs from the top right corner to the bottom left corner of the Edgeworth box. It passes through point G. At the top right hand corner, Richard and Seth will only produce and consume bread, while at the bottom left corner they will only produce cheese. Moving along the curve from top to bottom, they will be increasing cheese production at the expense of bread production. The contract curve shows the allocation of resources in production, but in many ways we're more interested in the consumption of outputs. While these are implicit in the contract curve, we can show them explicitly in a production possibility curve. Every point on the production possibility curve represents the outputs associated with a point on the contract curve. I've shown G to represent the same outputs as we've already seen. Where the curve meets the horizontal axis, only bread is consumed, and this corresponds with the top right-hand end of the contract curve. In the same way, where there is only cheese produced and consumed, the production curve possibility curve is at the vertical axis, and the contract curve would be at the bottom left-hand corner of the Edgeworth box. We'll not do it here, but it is quite easy to show that the slope of the production possibility curve turns out to be the relative price of the two goods. Usually we call this slope the marginal rate of transformation, since it tells us the rate at which the production of cheese has to be cut back to allow production of bread to increase. Hopefully, as soon as we talk about the marginal rate of transformation being a price ratio, you'll be reminded that in part 2 we found that the marginal rate of substitution for the goods was also their relative price. We'll find the same result in this kind of analysis. Here now we're constructing an Edgeworth box to show how factor inputs are allocated to production. We do the same to show the allocation of goods amongst consumers. The dimensions of the Edgeworth box for consumption goods are shown as the outputs from production. The allocation of goods can then be shown as a point within the box, here point H. We'll pass over most of the detail of analysis and instead simply concentrate on the final distribution of the goods. This should be Pareto efficient, as at H, so that for both Richard and Seth, the marginal rate of substitution is equal to both the price ratio and the marginal rate of transformation. We can show this in two ways. Firstly, as we've shown in this diagram, the indifference curves for Richard and Seth will just touch, with the slope of their common tangent equal to the price ratio. Secondly, the allocation lies on a contract curve. If we treat Seth's utility as a constraint, then the points on the contract curve show the maximum utility which Richard can achieve given Seth's utility. In the same way that we can create a production possibility curve from the contract curve showing Pareto efficient input allocations, we can also create a utility possibility curve from this contract curve. Its slope would show how Seth has to give up utility as Richard's utility increases. Now, all of this is possible, but we're left with one final question. And here I'm simply going to pose it, deliberately leaving you to think about the answer. Nothing in our discussion prevents us from having a situation where Richard generates a very high level of utility compared with Seth. The question for you to think about is whether that should be of any concern to us as economists.